Question 43. A person is standing on a truck moving with a constant velocity of 14.7 meters per second on a horizontal road. The man throws a ball in such a way that it returns to the truck after the truck has moved 58.8 meters. Find the speed and the angle of projection, A, as seen from the truck, B, as seen from the road. Solution. Velocity of the truck equals 14.7 meters per second. Distance covered by the truck when ball returns back to the truck equals 58.8 meters. A. Here, time taken by the truck to cover 58.8 meters distance equals time of the flight of the truck. T equals S upon V equals 58.8 by 14.7 equals 4 seconds. Let us consider the motion of the ball going upwards at T equals 4s. Time taken to reach the maximum height when V equals 0, where V equals final velocity. T equals T by 2 equals 2 seconds. Again, V equals U minus AT, where A equals G equals minus 9.8 meters per square second and U equals initial velocity with which the ball is thrown upwards. Gives U equals 19.6 meters per second. B. Seen from the road, the motion of ball seems to be a projectile motion, so total time of flight, T, equals 4 seconds. Let R be the horizontal range covered by the ball in this time, i.e. R equals 58.8 meters. We know the angle of projection, R equals U cos alpha T, where alpha is the angle of projection. And U cos alpha equals 14.7. Equation 1. Let us work on vertical component of velocity using below equation. V squared minus U squared equals 2ay. Substituting values V equals 0, final velocity, U equals 19.6, and A equals minus 9.8, or Y equals 19.6 meters. Vertical displacement of the ball at T equals 2s, Y equals U sin alpha T minus half a gram T squared. Or U sin alpha equals 19.6. Equation 2. On dividing 2 by 1, tan alpha equals 1.33. Or alpha equals 53 degree. Again, from 1, U equals 25 meters per second. Thus, the speed of the ball is 25 meters per second and the angle of projection is 53 degrees with horizontal. When seen from the road, Question 44. The benches of a gallery in a cricket stadium are 1 meter wide and 1 meter high. A batsman strikes the ball at a level 1 meter above the ground and hits a mammoth sixer. The ball starts at 35 meters per second at an angle of 53 degree with the horizontal. The benches are perpendicular to the plane of motion and the first bench is 110 meters from the batsman. On which bench will the ball hit? Solution. Width and height of the bench equals 1 meter. Initial speed of the ball equals 35 meters per second. Distance of the first bench from the batsman equals 110 meters. Angle of projection of the ball equals 53 degree. Or alpha equals 53 degree. Let the ball land on the nth bench if batsman strikes the ball 1 meter above the ground. Y equals n minus 1. Equation 1. And x equals 110 plus n minus 1 equals 110 plus y. Again, y equals x tan alpha minus gx squared sec squared alpha upon 2u squared. By substituting the values, we get y equals 5. Using equation 1, n minus 1 equals 5, gives n equals 6. The ball will hit the 6th bench. Question 45. A man is sitting on the shore of a river. He is in the line of a 1.0 meters long boat and is 5.5 meters away from the center of the boat. He wishes to throw an apple into the boat. If he can throw the apple only with a speed of 10 meters per second, find the minimum and maximum angles of projection for successful shot. Assume that the point of projection and the edge of the boat are in the same horizontal level. Solution. Initial speed of throwing the apple by the man equals u equals 10 meters per second. Length of the boat equals 1.0 meters. Distance between the man and the center of the boat, r, equals 5.5 meters. Acceleration due to gravity equals g equals 10 meters per square second. The horizontal range, r equals u squared sine 2 theta by g. By substituting the values, we get sine 2 theta equals 1/2, or theta equals 15 degree or 75 degree. For the end point of the boat, horizontal range, r, equals 6 meters. For the end point of the boat, we have horizontal range, r, equals 6 meters. R equals u squared sine 2 theta by g. Here theta equals 18 degree or 71 degree. For a successful shot, the angle of projection with initial speed 10 meters per second may vary from 15 degrees to 18 degrees or from 71 degrees to 75 degrees. Question 46. A river 400 meters wide is flowing at a rate of 2.0 meters per second. A boat is sailing at a velocity of 10 meters per second with respect to the water, in a direction perpendicular to the river. A. Find the time taken by the boat to reach the opposite bank. B. How far from the point directly opposite to the starting point does the boat reach the opposite bank? Solution. Distance between the opposite shore of the river or width of the river equals 400 meters. Boat is sailing at the rate of 10 meters per second. Rate of flow of the river equals 2.0 meters per second. Let versus be the resultant velocity of the boat when vertical component of velocity 10 meters per second. Takes the boat to the opposite shore. Time taken equals 400 by 10 equals 40 seconds. Now, tan theta equals 2 by 10 equals 1 by 5. When boat reach at point C from the figure, in triangle ABC. Tan theta equals BC upon AB equals 1 by 5. BC equals 400 upon 5 equals 80 meters. Also, V equals square root 10 squared plus 2 to the power of 2 equals 10.2 meters per second. Let alpha be the angle made by the boat sailing with respect to the direction of flow. Tan alpha equals 10 by 2 or alpha equals 78.7 degree. The distance boat has to travel to reach the opposite shore equals 400 upon sine alpha equals 407.9 meters. A. Time taken by the boat to reach the opposite bank equals 407.9 upon 10.2 equals 40 seconds. B. Distance equals square root 407.9 to the power of 2 minus 400 to the power of 2 equals 79.9 meters or 80 meters, approximately. Question 47. A swimmer wishes to cross a 500 meters wide river flowing at 5 kilometers per hour. His speed with respect to water is 3 kilometers per hour. A. If he heads in a direction making an angle theta with the flow, find the time he takes to cross the river. B. Find the shortest possible time to cross the river. Solution. Width of the river equals 500 meters. Swimmer's speed with respect to water equals 3 kilometers per hour. Rate of flow of the river equals 5 kilometers per hour. The swimmer heads in a direction making an angle theta with the flow. So, 3 sine theta is the vertical component of velocity which takes swimmer to the opposite side of the river. Vertical component of velocity equals 3 sine theta kilometer per hour. Distance to be traveled equals 0.5 kilometers. A. Time equals 0.5 h upon 3 sine theta equals 500 into 6 by 5 sin theta equals 600 upon sine theta second or 10 upon sine theta minute. B. Here theta equals 90 degree. Time equals 0.5 upon 3 sin theta equals 500 into 6 by 5 sine 90 equals 600 second. Therefore, shortest possible time to cross the river is 10 minutes.